In this lesson, I'll show you how to create this app that allows us to choose photos from the user's photo library. Then the picture animates in, and we can move the photo around by touching it and dragging it. And if we want to add more pictures, we can do that too. So let's get started. Open Xcode and create a new project. Choose the single view application template. I'm going to call the app Photo Touch. Make sure that the Use Storyboard and Use Automatic Reference Counting are checked. Then click Next and create the project. Let's start building this app by adding our user interface images. I'm going to drag in an add button.png and a wood texture.png. Now go to the main storyboard.storyboard file and drag an image view onto the view controller. We'll use this to hold the background image. So let's add our wood texture.png as the image to this image view. Make sure the image view is selected and then hit Command equals to make the image view the same size as the image. Now I want to get rid of this status bar at the top of the view controller. I can go to the view controller's attributes inspector and change the status bar to none. But now when I run the app, the status bar is still there. And that's because when the iPhone first starts up, it reads the initial settings from the info.plist file and sets up the app from those. You'll find the info.plist file under the supporting files. These are settings that define app properties like the name to display under the app icon, and we can also add certain settings that aren't already here. To make the status bar hidden when the app first launches, we'll add a row and scroll down to the bottom until you see the setting status bar is initially hidden. And then we can change the value to yes. Now we can run the app. And the status bar really is hidden. Now let's go back to our storyboard file and add a button that the user can tap to display the image selection view. In the attributes inspector, set the image for the button to be add button.png. Then set the type to custom. Then select the button and hit Command equals to make the button the same size as the image. Now let's switch to the assistant editor and create an action for when the button is pressed. I'm going to call the action add button pressed. Now let's switch back to the standard editor and select our tadviewcontroller.m file and scroll down to where the add button pressed method is defined. This is where we want to show the user the view where they can choose their own images. Apple handles the image selection view for us. It's called a UI image picker controller. We just need to show that view to the user, and then when the user picks an image, the picker view will inform its delegate what image was picked. The first step in showing the image picker is going to be to create one. Now we need to set up our image picker before we show it. The first thing we'll set is its source type. The source type is what controls whether or not the user can pick an image from their photo library or use the camera. To allow the user to choose a photo from the photo library, we'll use the photo library source type. Unfortunately, the iPhone simulator doesn't allow us to use our computer's camera to simulate the iPhone camera and take pictures directly. But the methods and objects that we use for choosing photos from the photo library are the same as using the camera. The only difference is the source type. Once you've signed up for a developer account and you're able to test apps on your device, you'll be able to easily change this app to use the camera to take pictures by changing the source type of the image picture from photo library to camera. Now if we wanted, we could allow the user to select videos by setting the media types property. But it's set to photos only by default, which is what we want for this app. So the only other property that we need to set is the delegate, which we'll set to be this view controller object. If we click on this error message, we can see that the delegate needs to conform to both the UI navigation controller delegate and the UI image picker controller delegate protocols. Let's declare that this view controller conforms to those protocols in the .h file. And now we can show the image picker controller over top of this current view by calling the present view controller method on this view controller that's currently showing. The last parameter that we send is the completion block. A block is a section of code that we can run at a later time. We'll talk more about blocks in a minute, but for now just put null, which is like saying nothing for a block. Let's run the app and see what we've got so far. So the photo library pops up like we expected, but we don't have any photos. Let's add some photos to the iPhone simulator. The easiest way to do that with just a couple photos is to drag in one at a time into the iPhone simulator. The iPhone simulator will open the photo in Safari. Then you can hold down the mouse on the photo and select Save Image to save it to the photo library. Let's do that with the other photo I've got here as well. So now we'll actually have photos to choose from in the UI image picker controller. Let's write code to control what happens when the user chooses one. When a photo is chosen, the image picker controller informs the delegate, which we set to be this view controller object. So let's define the UI image picker controller delegate methods. The first is the image picker controller didFinishPickingMedia method, which gets called when the user picks an image. The second is the image picker controller didCancel method, which gets called when the user doesn't pick any image. In both of these methods, we want to dismiss the image picker to return back to our main view. Since this view controller presented the image picker controller, we can just use the dismissViewController method to dismiss the image picker. And let's put that same line at the end of the image picker controller didFinishPickingMedia method. Great, now we've got all of our view controller management done. Now when the user selects an image, I want to display it on the screen. We've created all our user interface elements using Storyboard and Interface Builder in the previous lessons. But here, since we'll have a variable amount of image views, we should create an image view in our code when the user selects an image and then add that new image view to our main view. To create an image view, we'll allocate a UI image view and use the initWithImage initializer method. The initWithImage method accepts a UI image object that it sets as the image in the image view. But we don't have an image yet. Let's get the image that the user picked. That UI image that the user picked is passed along in this info dictionary. We can get the image with Apple's predefined dictionary key, which is UI image picker controller original image. And now we can set the image to be in the image view. We also need to set the size and location of the image view using the set frame method. The set frame method accepts the CGRect struct, which consists of an X and a Y coordinate that position the upper left corner of the image view on the screen. There's also a width and height that set the size of the image view. We can create a CGRect struct with the CGRect make function. I'll put 0, 0 for the X and Y and put a width and height of 80. This will put a square 80 by 80 image in the upper left corner of the screen. It's important to note that we're working with points here and not pixels. In a normal display like the iPhone 3GS, 1 point is 1 pixel. In a Retina display like the iPhone 4, 1 point is 2 pixels. Running the app in the Retina display simulator will give us the same proportions to all our elements, so everything will work the same and we don't need to write separate code for each type of display. Now I'd like to change the position of the images to be random so that when we add new images they won't be directly on top of one another. We can generate a positive random number with the arcRandomUniform function. The iPhone screen is 320 points wide, so to use the whole width of the screen and not have the image cut off, we'll set the upper left corner to have an X value of between 0 and 240. We got the 240 by subtracting 80 from 320. I also don't want the Y value to be too far down and come close to covering our add button, so I'm just going to choose a Y value that's between 0 and 300, which should be plenty of room since the iPhone screen is 480 points high. Now we just need to add the image view to our view. We can do that by getting the view controller's view and then using the add subview method to add the image view as a subview to the view controller's view. And that's everything. Let's run the app to see how that works. So we can add an image, and it shows up in our app in a random position. And then we can add another image, and another image view is created and added to our view. Great, but I think it would look better if we animated this picture into place rather than just made it appear. To do that, we'll have to learn about blocks. Blocks are simply sections of code that you can store and/or execute later. They're designated by the caret symbol and followed by curly braces containing your code. Blocks can also accept arguments, just like methods can. Here the block accepts a finished Boolean value that the code inside the block can use. As we saw earlier, the dismissViewControllerAnimated method accepts a completion block at the end of the method. This is code that will execute when the viewController's dismiss animation has completed. Let's say that instead of adding our new image view before the viewController is dismissed, we add it after. We would add the code to do that in a block. So we would first designate our block and then put the code inside it that we want to execute. In this case, it's the add subview code. Now let's add that to our app. So I'm going to delete null and put the caret and curly braces around our block. And now I'm going to cut the add subview line from above the dismissViewController method and paste it in the block for the completion parameter. Now instead of adding the image view to our main view before the viewController has been dismissed, the viewController will first finish its dismiss animation and then the new image view will appear. Great. Now let's make our image views animate. Animations methods are called on the UI view class. You can then pass in an animation block with the code that you would like to be animated. To animate our view controller, let's set the initial position of the image to be off the screen at -80x and -80y. Now let's set up an animation by calling the animate with duration method inside the dismiss view controller completion block. I'm going to set the animation to 0.5 seconds. And here we'll put a block with the code that we would like to be animated. I want to animate the position changing to the random position that we had earlier. So let's put that set frame method here inside a block. And now let's run the app. Great, after the image picker controller is dismissed, our new image view animates into place. We can animate all sorts of properties on our image view. Let's try to make the image larger and set the opacity to slightly transparent by setting the alpha value. Everything looks like we expect. You can continue to play with that by animating any of the view's animatable properties, which are the frame, the bounds, the center, the alpha, the background color, the content stretch, and the transform. For now, let's change our size back to 80, delete the alpha animation, and change our animation duration to a more reasonable 0.2 seconds. So far in this lesson, we selected images and then created image views for those images, and then animated them into place on the screen. Now let's add the ability to interact with those images by dragging them around the screen. To do that, we'll use objects called gesture recognizers. Gesture recognizers can be added to views so that your app can be informed when certain gestures are performed on the view, like pans, taps, swipes, pinches, rotations, or long presses. They work by first creating the type of gesture recognizer that you'd like to add. In this case, it's a pan gesture recognizer, which happens when the user touches the screen and begins moving their finger. We're initializing the gesture recognizer with a target and an action. When the gesture recognizer recognizes the pan gesture, it will call the action on the target. So in this case, the pan gesture recognized method will be called on the object SumObject. You can then apply the gesture recognizer to a view that you'd like to recognize that gesture on. Then when the user touches some view and starts to move their finger, the pan gesture recognized method will be called on some object and the app can take action. Let's go back to our code and add gesture recognizers to our image views as we create them. We'll add pan gesture recognizers so we can detect when the user is moving their finger on the picture. We can then use the information from the gesture recognizer to find out where the user has moved their finger and adjust the position of the image so that it's always under the user's finger. The first thing we need to do is make sure the image view can accept touches. We'll do that with the set user interaction enabled method. Now let's create a UI pan gesture recognizer after we create our UI image view. Let's create it so that it calls the method pan gesture recognized on this view controller object. And now let's add the gesture recognizer to the image view with the add gesture recognizer method. And that's all we need to do to set up a gesture recognizer. Let's decide what our app will do once the gesture is recognized. First, we'll have to define the pan gesture recognized method that's called when the gesture is recognized. When a pan gesture recognizer calls its action, it passes itself into the method. We can use the location in view method on the gesture recognizer to find out where the user has moved their finger. The method returns a CG point, which is an XY coordinate, that responds to the touch in relation to the main view. We can use that to set the center point of our image view. We aren't holding the image views in any variables, but we can get them from the gesture recognizer by asking the gesture recognizer for its view. Let's run the app to see how that works. Great, we can add an image and move it around. There's a problem when we add a second image though. I'd like for whatever image that I'm touching to be on the top, but the most recently added image always stays on the top. We can rearrange our views by calling the bring subview to front method on the view that holds all the image views. And that's almost everything. Let's finish this app by adding a sound effect for the image that's animating into the view. Apple provides several different ways to play audio on the iPhone. For UI sound effects less than 30 seconds long, where you don't need a lot of pan or volume control, Apple recommends the simple Audio Services C API. We'll be using 3 Audio Services C functions, one to create a sound, one to play it, and one to destroy it. The C functions are in the Audio Toolbox library. Let's include that library in our project. And let's import the Audio Toolbox library into our .h file. Now let's declare a variable to hold our sound in the viewController.h file. I'm going to declare this variable without the @property declaration to show you how to do that. When declaring variables without the @property, we need to add curly braces to hold them in the .h file. And the type of variable that we need to hold our sound is called a system sound ID. Now back in the .m file, let's create the sound in the viewDidLoad method. First, we'll need to put the sound in our project. Drag in the click.aiff file. When we drag resources into our project structure like this, they are by default included in the app's bundle. The bundle includes all the resources like UI images and sounds that your app needs when it runs. We can get to the bundle by using the main bundle method on the NSBundle class. And now we can find the URL file path for our sound effect by calling the URL for resource method on our bundle. And now we create the sound with the C function Audio Services create system sound ID. There are two things that we should talk about in this function. One is we get an error here that we're passing an NSURL parameter to a CFURL ref. That's because this function requires the C version of NSURL, and I'm passing the NSURL object. Luckily, NSURL and CFURL are something called toll-free bridged, which means we can use them interchangeably. We just need to indicate how we're going to do that. We can do that by adding bridge CFURL ref in front of sound URL. This indicates that we're bridging the NSURL object to become a CFURL C type, and our warning has gone away. You may also find this AND symbol confusing. Some C functions ask for the memory address of where you want the result stored. This is indicated by the star character appearing in our function definition. We want the sound that is created to go into our mySound variable. To get the memory location of that variable, we just add the AND symbol on the beginning. And now to play the sound, we simply use the playSystemSound function. Let's add that in the dismissViewController block in the ImagePickerController didFinishPicking media method. And finally, when we use a C method with the word create in it, like we did when we created the sound in the viewDidLoad method, we need to counter it with a dispose method. If we don't, the sound that we created will stay in memory even though it's not being used, and this is called a memory leak. To dispose of the sound when the app is finished with this view, we'll use the dispose system sound ID function in our viewDidUnload method. And that's all we need to do to play sounds. Let's see how that works. Great, that's everything. In the challenge for this lesson, try to add a tap gesture recognizer that will make the photos expand and shrink again when they're tapped. In the solution, I'm going to use a different animation method than the one we used previously, and I'll be animating the bounds property of the image view. There will be a solution video for the challenge, and then in the next lesson, we'll learn how to submit this app to the App Store.